In the world of vectors, there's a story to tell of why y hat any forming a right triangle so well. Where y hat equals x beta, a linear combination clear of x-plane column vectors. Let me make this idea near. Let's derive the projection matrix step by step from normal equations. A logical prep beta hat equals x transpose x inverse x transpose y. Substitute into y hat equals x beta hat as we try. X transpose x inverse x transpose y is what we find. Let's call it py. Keeping math in mind, so y hat equals py. That's our projection. P equals x transpose x inverse x transpose without objection. That's our projection matrix onto the x-plane. The hat matrix, as some like to name. Projection geometry, mathematical clarity. Vectors falling into place with such regularity. From high-dimensional space to a simpler view. Least squares through projection is what we do. Check the properties of P. Our projection guide. Project what's already on x-plane. Nothing change inside. For example, py is x's linear mix. So py equals x beta hat. P times py equals p x beta hat. Follow me where we're at. Woo! X transpose x inverse x transpose x beta hat equals x beta hat equals py. And impotent matrix powers don't multiply. P times p equals p. That's the key inside projection. Apply twice gives the same result, right? Now for y's projection to x's orthogonal space. Residuals e equals y minus y hat. In this case, e equals I minus p. The formula clear. I minus p project to the orthogonal sphere. A vector on x-plane projected orthogonally. I minus p x beta hat equals x beta hat minus p x beta hat vanishing completely. Real data follows y equals x beta plus epsilon. Error terms adders to what we aim to rely on. Let's deepen our understanding with this model in mind. Projecting true signals from noise we'll find. Substitute real data into our projection equation. Y hat equals py equals p x beta plus epsilon. No complication. X beta lives on x plane, so p x beta equals x beta. Thus y hat equals x beta plus p epsilon. C are fitted values combined. The true model indeed, with projected error components mathematically freed. For residuals with real data, let's explore more. E equals I minus py as we saw before. Substitute y equals x beta plus epsilon to reveal E equals I minus p x beta plus this is real. Since I minus p x beta equals 0, we see E equals I minus p epsilon geometrically. Residuals are error projections orthogonal to x. The math of least squares, elegant and complex. Projection geometry, mathematical clarity. Vectors falling into place with such regularity. From high-dimensional space to a simpler view. Least squares through projection is what we do. Of vectors and planes, least squares estimation geometrically explains how to find the closest point in the column space. Projection matrices guide us through this mathematical chase.